2018-2016 Junior Certificate Materials Technology Wood, Section A Short Questions on Gearing Mechanisms. Higher level. Okay, so taking a look at this question that I asked you to do, it's from the 2016 paper and it's question 9 out of section A in relation to gearing mechanisms. Now, things that we want to start working on is definitely neatness and presentation. The quality of the work that you've been handing me up is not what I would consider as good as it could be. So when we're lining out a sheet, again, the date is very important to let you know what day you did this work, what it relates to. We're dealing with gearing mechanisms. This is from the 2016 Junior Cert examination, section A, and it's question 9. And again, in the margin here, we put in question 9. All of this put in red pen because it's a heading. Now, these are important to get right. You want to present your work as good as you possibly can. Now, reading the question, angled chucks are often used in compact drills to reach confined spaces. The diagram shows a set of beveled gears from an angled chuck. If the smaller gear rotates clockwise as shown, use another arrow on the diagram to indicate the rotational direction of the larger gear. Now, these are fairly straightforward questions. We have this wheel here that is spinning in a clockwise direction. So as the teeth on that gear wheel engage, and if this is spinning clockwise, well, it is going to spin this gear wheel in the opposite direction. So very simply, we put an arrow just above the gear wheel that shows that this gear wheel is moving in an anti-clockwise direction, and that answers the first part of the question. Indicate the rotational direction of the larger gear. Moving on to the second part of the question. The small gear has 12 teeth and rotates at a speed of 60 RPM. If the large gear has 36 teeth, what is the rotational speed of the larger gear? Now, some of you were having problems with this. And just to again explain what is going on here. So in the question we were told that this small gear wheel has 12 teeth and it is spinning at 60 RPM. So in a minute, this gear wheel here will have spun around 60 times. It has 12 teeth on it and it is spinning at 60 RPM. So we need to find out how many times the teeth on this small gear wheel are going to engage with the teeth on the bottom gear wheel in order to solve this question. So we have to find out how many times in a minute will the teeth on this gear wheel engage with the teeth on the gear wheel below it. So in order to find the number of teeth that are going to pass by in a minute, it is the number of teeth on the wheel multiplied by the rotational speed. So to work out the total number of teeth that pass by in a minute, it is the RPM, which is the rotations per minute. Rotations per minute. So that means that in a minute, that wheel there is going to spin around 60 times over a minute. That means it spins around once every second. So we take the RPM and we multiply it by the number of teeth on that wheel, which is 12. 60 multiplied by 12 will give us the total number of teeth that pass by in a minute. So when we work that out, we get a figure down here of 720. So we know that as that wheel there now is spinning around for 60 times in a minute and there are 12 teeth on it, there are going to be 720 teeth engagements in the wheel below it. Now, the wheel below has 36 teeth on it. There are 36 teeth on this. So we need to find out now how many times the 36 teeth on the bottom wheel engage with the 720 that the rotational speed of the top wheel is producing. And to work that out, it is 720 divided by 36. So looking back at the question, we can see that the large gear wheel has 36 teeth. So to calculate the rotational speed of the larger gear wheel, it is the number of teeth after 1 minute that is produced by the smaller gear wheel turning. So that there is 720. Divided by the number of teeth on the larger gear wheel, which is 36. So we divide 720 by 36 and that gives us a rotational speed of 20 RPM, and that is the answer to the question. And then we fill that speed in here, 20 RPM. So just a quick recap then on the question. So as I stated at the beginning, make sure that you put in an effort to keep the presentation of your work as good as you possibly can. The date, the heading, what we're actually working on are all very important. Again, put in red pen as a heading, line in your margins and all that kind of work. Now, looking at the question, the first part asked us to identify what way that this gear wheel was going to spin. And if you see there, the smaller gear wheel with the arrow indicated on it is rotating in this direction. It's rotating clockwise. As the teeth on this gear wheel engage into this one, it's going to force that one back. So that is spinning anti-clockwise, and we indicate its direction with an arrow, and that answers the first part of the question. Moving on to the second part of the question, we want to calculate the rotational speed of the large gear wheel. Now we're told that this gear wheel here has 12 teeth on it and it is spinning at 60 RPM. So you have to find out the number of teeth that are going to pass after a minute. And that is going to be very simply the rotational speed per minute multiplied by the number of teeth gives us 720 teeth. Now, once we have that figure there, 720, we then take the number of teeth on the bottom gear wheel, which was 36, and we divide them into 720, and that gives us a figure of 20 RPM, which we write up into this area up here. So that completes the question there. A very straightforward enough question. Those gear calculations, it's all about just thinking about the rotational speed and the number of teeth and then working it out as best you can. So that completes Section A 2016, Question 9 on gearing mechanisms. So after looking at 2016, we want to consider 2018 Junior Certificate Higher Level Section A Question 12. Now, reading the question, it says, the diagram shows a flexible angle chuck which is used when drilling in confined spaces. Bevel gears as shown are used in these chucks. If the smaller gear rotates clockwise as shown, use another arrow to clearly indicate the rotational direction of the larger gear. Now I'll leave that to yourself, but you can see the arrow there is indicating that this gear wheel is spinning in this direction. So what will that do to the gear wheel below? Now we are told then that the gear wheel, the small gear wheel has 10 teeth and it's rotating at 80 RPM. So this has 10 teeth on it. It's rotating 80 times per minute. So in order to work out the number of teeth engagement, it's going to be 80 multiplied by 10, which is going to give us 800. Then we have 50 teeth on the gear wheel below. So you take the 50 and divide that into 800, and that then will give us the rotational speed. Now, I want you to do that question yourself, work it out, and lay the question out exactly the same as the 2016 question. So write down all the relevant information as I did in the 2016 question and answer that. So when you're doing the 2018 question, I want you to follow this format here. So you start off by writing the total number of teeth in 1 minute is the RPM by the number of teeth. That there for the 2018 question is going to be a rotational speed of 80 RPM multiplied by 10, which is going to give you 800, and you write it out in this format here. Then we go on to the RPM of the bottom gear is going to be the number of teeth after 1 minute by the number of teeth on the big gear wheel. So that's going to be 800 divided by 50, and whatever answer that gives you. But I want you to write it out and lay it out in that format on the page. Now again, pay close attention to the presentation of your sheet with headings, the question and the calculations. And make sure that you lay out your work as neat as possible and do both of those questions.